result in in customer satisfaction and return on investment as well. I have driven Industry 4.0 practices for all the 6 years and even worked on operational talent strategies. I have worked with industrial insight and software consulting integration firms as well. Since I'm based in Mumbai, Nashik, Pune, which is industrial corridor, I have most of my work focuses on insights and helping large industrial companies get to the Industry 4.0. So basically, IoT or Industry 4.0, IoT or Industry 4.0 starts with IoT. And what is IoT basically? It's a system of interconnected digital devices, machines, objects, even animals and people provided with unique identifiers. I have a very interesting use case about that, which we'll get to later. Basically, IoT is all about the ability to transmit and share data over network without the need of human to human or even human to computer interactions, basically. So what are things when we talk about IoT or Internet of Things? The basic thing starts with the things. So things can be any physical object that can transmit data with its inbuilt systems, or you can even embed things with newer communication modules which will allow it to transmit the data. So when you talk about IoT, that does not stop from being an IoT system, or it doesn't complete the IoT system until and unless you have a communication channel that starts with things, goes on to the communication node hub, and back to the cloud. And once it's processed there, the cycle has to complete. Basically, by that I mean you have to analyze the data, you have to process the data, you have to create insights out of it, and then based on that, you have to send an alternate action back to the thing through the same channel or some other probably. So that's basically all about things. There are two types of things available, which are brownfield things and greenfield things. So brownfield means something that we already have, and as you know, India is a very cost-effective market, right? So everybody thinks about costs before implementing any new solution or strategy. So whichever company you will join, they will first think about the cost of implementation, right? And if most of the companies in India, including MSMEs, right, they already have all the machines available, and just to make it Industry 4.0 compatible, they are not going to scrape their existing infrastructure. They are not going to throw away their existing machines, which actually costs in crores, right? So basically, brownfield is the ability to get those systems on board and make those systems, communicate with the latest. Hello. Yeah, so as I was saying, brownfield is basically important to industrial IoT, such as smart buildings, bridges, roads, railways, and all the infrastructure that we have, because the costs of replacing these things is very high. So instead of that, we just upgrade them with some communication factors, right? And greenfields are the things that you see in the market now, right? Including your smartphones, including your digital gadgets such as cameras with Wi-Fi, even your smart cooking apparatus and washing machines and fridge, and even your fans and AC, right? Everybody is talking to internet right now. Everybody can operate things from the internet directly with just a Wi-Fi connection. It could be local, it could be over the internet, but at the end, it's all about the greenfield technology, right? Which actually has the higher cost rate. So if you go for things without IoT and then implement the IoT on your own, it will be cheaper, but it may not be standardized and it may not be secure as well. But if you go with the greenfield, then you get all those things incorporated already. So what are the things that we are talking about, right? So things could be sensors, which actually sense. There are basically two different types of things. One are the sensory type, which actually gives you information by converting some analog parameters into digital ones, or even a few directly getting digital values. And there are actuators, which actually take action, right, based on the information or the commands given. So basically, IoT things are comprised of these two separate modules that you can say. One is the sensors and the second is actuators. So when the first one works and gives us the data, we process the data and give back the analyzed information, and based on that, the derived decision part, right? And it is given back to the actuators. So to do that, we need a medium for communication, right? So the way we currently communicate is over a WebEx. We are using basically a lot of techniques, like I'm using vocal systems, I'm using our English, which is a generally accepted language, that is a communication protocol for us. And again, we are using WebEx, which is a tool, right? So basically, to enable things to communicate over a channel, we can use multiple things. Which can be, as you can see, some of them I have listed here, which are generally used in the industry. ESP8266, which is Wi-Fi chip, which enables you to communicate or connect with the regular sensors or other devices, and collect its data on board, send its data over the Wi-Fi to your servers or any other network, right? Then you have GSM adapters, which actually enable you to have GPRS communication, or you can have SMS or even calls made, right? Then we have BLE, which is short bandwidth, short length communication, which uses very less power and is very effective in terms of having where you don't need a lot of power, or you don't need to send the data over long distances, but you just need that device to be working for a long time without replacing the battery. Then we have recently two technologies, which are NB-IoT, which is a narrow band IoT. That's a separate satellite band allocated just for IoT communication by the government. And then we have LoRa, which is a long range communication. Basically, both of them work with satellites. Both of them have their proprietary security channels. Both of them require you to have a subscription to a cloud-based service, who are authorized to work in those communication bands, and then you send your data from your SIM to NB-IoT or LoRa. The provider then collects that data over their own platform, and then share that data with you wherever you need it. And then we have vision based communication, which is ZigBee, right? So ZigBee is kind of a mesh network where you can communicate over other ZigBees, and it will create a network of multiple ZigBees to, even though first sensor might not be in the visibility range of the last one, but still the information will get delivered at the end, right? So there are different channels, like wired channels and wireless channels, as we have seen, right? Bluetooth and Wi-Fi, which is what we use every day, and we use a lot of cables like LAN cables, modem cables. Even currently we are using now Ethernet for internet, right? Basically, that's the biggest one, and now we have fiber connections, which are very high-speed internet connections available. So the communication architecture that traditionally has been followed for all the communications in computer history are again reused by the IoT, which are basically a client-server model or a peer-to-peer model. So client-server, if you think about the Modbus as a communication service or the protocol, then client-server will be the go-to architecture, because when you are sending a command to a Modbus-based machine, like you want to get its parameters, you want to get some, or you want to set some parameters, basically you are utilizing the client-server request. But when you are attending the WebEx call, or sharing your files or playing multiplayer games online, you are basically in a peer-to-peer internet or peer-to-peer network or the internet, right? Some of the evolved communication protocols over the time, the basic starts with the RPC, which was a remote procedure call. So whenever we write a program and you need to call it from some other process, so that was the very simplest form of communication, which was RPC or remote procedure call, which later evolved with a lot of security parameters to SOAP. And currently we have REST services everywhere, which all of the devices, all of the applications consume, and which is very easy to implement as well. It uses a simplified JSON structure to implement, and you can send all of the data, very lengthy data as well, at very long locations. So MQTT is one of the newest communication mediums or protocols available for IoT, and this makes perfect sense for IoT because MQTT is a broker-based system, which means you have a broker sitting in between. Unlike the REST systems or RPC calls, right? which has a client-server architecture. MQTT has a broker inside which sits and which actually transmits or governs the communication basically. So whenever you are whenever device creates its own data and sends it over a particular channel, let's say Wi-Fi or even Bluetooth, then it is received at the broker, and whoever has subscribed to that particular information will get that data irrespective of the device being in its range or not. So basically, if you think about an example here, you can think like if you have a temperature sensor at your home, right, and you have a fan, an AC, a lot of things which actually are operated digitally. So you can have a broker sitting in between which actually communicates or gets the temperature sensor data every hour or so. And when if decides to, whoever has subscribed to that temperature information or value will get that data once the broker has it. So basically, you can at the same time subscribe to multiple devices as well as publish the data as well, just like your AC does. It simultaneously receives the data and generates the data as well. Then we have Modbus, which is universally accepted standard of communication, de facto communication, basically in all the industrial environments. It has, as we discussed earlier, master-slave kind of architecture where a master will send its commands or a set of programs that gets pushed into its registers and decides or dictates what action should be taken by the end machines, right? And vice versa. Like if a master needs some data from the machines, some parameters, then it can again send another command which actually reads the data from the registers of the slave devices. We have a CAN bus, which is mostly used in automotive vehicles, basically. So all the vehicle parts, including brakes, lights, backlights, everything works on CAN bus. So everybody is at the same time, publishing their own information on a single channel. So whoever needs that information can just, just use those exact parameter variables and decode those and get the value basically. So it's a live channel communication, and CAN bus is one of the very easy to use communication platforms because it's continuously live, but the cost again is very high as compared to the MQTT, which is as and when needed basis communication protocol. So as you can see here is the adapter for CAN bus communication. If you have a four-wheeler at home, you can even buy this very cheap adapter and get all the data. It's basically an OBD2 interface, so it will send data to your mobile application over Wi-Fi or even Bluetooth. So you can look at all how the brake has worked till now, how much pressure you have applied, how much tire pressure is available. Everything will be available, right? Then we have SNMP and OPC, which are standards. SNMP is the standard protocol for routers and even your printers. Very simple network management protocol, which has some OIDs and MIBs, which actually are just numbered strings, which actually map into its command. So basically, once you send that a string of digits with 0.12.13. Something like that, and it's a very big string for each of the specific commands. So if you send one of those to your routers, you can even get its uptime, you can get the data it has transferred. So basically, all the communication or all the data that a router has to do, it works over SNMP. Even your Windows-based machines or any laptop systems that you have, you can even get their data like free memory, resource utilization, everything over SNMP. Then we have OPC, which is again OPC UA and DA are two different protocols completely, which one of them is open source and the other is proprietary by Microsoft. So most of the people go with the open source one, and it is again used in robotics controlled environments in industries. Lastly, we have Zigbee communication, which is used with where there are overhead cranes and large equipment, and where the industrial area sizes between a few hundred meters to a few kilometers as well, right? Like Tatas and JNTs and JCBs, right? So they have areas ranging over a few kilometers, right? And they need to send data like one part is ready for movement to another shade or coloring or whatever. So when that is happening, that transmission is happening of that part, the data is sent over ZigBee. So basically, it is a visibility-based network where the data gets transmitted for from few meters to few hundred meters, and you can create a hybrid chain which will automatically connect with the nearest ZigBee device available and transmit the data that it is receiving until it finds its final receiver. And we have LoRa, as we discussed, which is a long range. So there are a few, Saket and Sendra are two of the most prominent players in LoRa space, and they have their own platform. So basically, what they even have some free usage limit. So you can even sign up and you can send your sensor data to them over LoRa. So what you will need basically is a LoRa communication enabler gateway, which will send the data to your own application interface, and you can access it over there. So, but again, this uses very low power, so it's very much suitable for all the building environments, smart buildings and smart infrastructures basically. So all of this communication that we just discussed happens in 3 different stages or in 3 different parts that we can think about. One is edge, the second is fog, and the last one is cloud. So edge is all about collecting data locally from things and communicating it back to local things, right? Like your Wi-Fi router without an internet communication. That will be, or even your doorbell, right? That's just an edge communication. But when we think about fog, that means you have a network of multiple such devices. So when we are thinking about building management systems, right, where there are multiple apartments, multiple flats in each of those apartments, but you don't want to send that data over to cloud, which can be insecure for the communication, then you have to create a fog basically, which will manage the things and even the gateways as a part of its own internal network. And lastly, we have cloud, which actually increases our scalability, increases performance, because there are so many things that you don't need to care about in the cloud, because again, you are just renting them as and when needed basis, and even the costs are very low because again, whenever you are not using those services, you don't need to maintain them, and that reduces the cost, right? So if you think about the implementation levels, right? So first is software as a service, right? Whenever you are implementing an IoT or IIoT solution, the simplest way to start with software as a solution, that means you only install your own software or use a software basically hosted by one of the cloud providers. Like the one that we are currently providing is called Plum Smart, which actually handles all the bathroom related devices that you install in your bathroom, including flush, faucets, backflow water management, and all the backnet related data as well. So you just have to log into the portal and you can see how much water has been utilized by each individual faucet or flush valve, and you can even manage the water flow. You can manage, you can create analytics like how much water you are going to need and you are going to consume. In US, they have a LEED standard, which means leadership in energy and environmental. Basically, it gives you tax benefits if you use reuse the water and reduce the consumption of water and energy. So if we have enabled a lot of buildings which actually take care of their own water usage and reuse that water, and get benefited out of it, and even environments benefit out of it, right? Very simple model where you just need to log in and see your data. Next is platform as a service, where you are not caring about what kind of system you have, but again you have to care about the application as well, where you have your own application. Most of the industries you can think about have their own applications hosted, and they are used internally for smart factory. So that can be counted as a platform as a service. And when we talk about infrastructure as a service, that's as good as having our own service but in the cloud. So whenever you are using that particular entity or that particular VM or any other resource that you are using directly will be counted as the infrastructure as a service. So IoT testing or basically security is one of the biggest aspects in IoT, and the testing can happen in these respective fields, right? First, you have to test the devices, device physical security, hardware, QA inspections. Then you have to check firmware, software that it's going to communicate with. Is it encrypted communication? Then the cloud subscription, if it's available, and again the radio channels that it's going to communicate through. Security, as I mentioned, if we implement the IoT in large scale, and if some attacker gets through one of the devices, then he has access to all of the devices basically, which can result into a bigger catastrophe, like it has already happened over the internet, right? And basically, Internet of Things became Internet of Threats, right? So how do you identify vulnerabilities, right? You have to, these are some of the basic guidelines that you can do, right? You have to make a recon, you have to identify what kind of chips you are using, you have to understand what kind of ports you are making available online, which kind of ports you should not be making available for the clients, and do you have authorization and authentication in place. All of these are standard practices, right? And these are some of the steps you can follow. I will obviously share this with I have this over my blog, so I'll share it afterwards. And again, this is a very interesting field to get into because IoT security is growing at a very, very large scale. Lastly, in the IoT space, even though we think of these things as a separate technologies, 3D printing and VR and AR and robotics, all of these things, right? And you think of IoT as a separate thing or a technology, but IoT is rather an umbrella term for all of these technologies combined, right? So basically what you are looking at, everything will be generating data, and all of that data will be consumed for making some of the decision points, right? And that decision will eventually affect the things back again. So it completes the IoT circle, and hence it can be termed as one of the parameters of IoT technology, right? So now we're talking about Industry 4.0, right? But the question we have to ask is Industry 4.0 coming, or is it already here? I mean, I think it really depends on who you're going to talk to. If you talk to, particularly European side of things, it's now prevalent in Europe. It's actually started in Germany itself. So when we talk about industrial revolution, as you can see, first and second industrial revolution were mostly about create mass production, right? And then we have moved on to PLCs in 1970s, I think, or so, and then we have arrived to cyber physical networks, which in 2011 in Hanover Fair in Germany, they created the concept of Industry 4.0. So what is Industry 4.0 and how is it different from IIoT or even IoT, right? So Industry 4.0 is basically about creating that compatibility between multiple segments of a business. Basically, it's about real-time data and availability of equipment information, and making that available to all of the stakeholders in your industry. So start with a little bit of what is Industry 4.0, and again, government of Germany coined that term since, right? And it was to they were basically looking to improve the competitiveness of German manufacturing industry. And there's a lot of different things that make up your Industry 4.0. There was a lot of automation around sensors. Different approaches to IoT comes into play as well. But fundamentally, the basis of it is using real-time data from your equipment to make information, make decisions, and those decisions are used to improve your processes. And they could be manual decisions, or they could even be automated, and even could be people doing it, right? Or even machines. But fundamentally, it is about reusing good data to make good decisions, and that's the fundamental, right? I could have coined the whole kind of concept as Industry 4.0 plus, where industrial internet equals competitive advantage. So it's more around strategy and a philosophy, plus the technologies and enabling technologies that give you advantages that are there are CPQ platforms, MES, ERPs, and there's a lot of different pieces that kind of strategy and philosophy includes approaches and Lean Six Sigma, Lean manufacturing technology, Six Sigma practices. All of these are basically utilized in creating the Industry 4.0 or IIoT. Right? The people aspect of it is that industrial internet side of things around those enabling technologies. Everything is connected, and people, devices, machines that use IoT services, and even prototype sensors, wireless sensors, everything basically amalgamates into this whole thing, right? But because IoT is not going to give you everything that you need, right? Till now we have talked about just IoT, and now we are getting into details why IoT and IIoT are different, and why Industry 4.0 is a completely different segment out of it, right? These are just co-balancing factors you can see, right? When we think about IoT, we are only thinking about the data that we have. So but we have to also make use of artificial intelligence and machine learning to give you those analytical tools, and the end result is trying to reduce downtime, right? Trying to improve your OEE, that is operational equipment efficiency, and improve the visibility of what's going on in your operation. And then that leads to increase in revenue, profitability, and I'm sure once you join your companies, your management and your executive team is what they'll be focused on, right? So that's where it comes, like reducing the downtime and increasing the revenue. So basically, it just kind of lays out there the framework. Industry 4.0, you can say it's just a framework or a way of kind of thinking about it. Maybe a simpler form of, but one thing I will say is IoT and industrial Internet of Things is not a silver bullet, right? And there's a lot of vendors out there which will sell you their own platforms and telling you, like, we have IoT capabilities, we have some ML, some AI parts within the platform, and you can, once you have it installed, you have everything for Industry 4.0 already. But that's not the case. That's what I'm telling you here. Because again, IoT and Industry 4.0 is basically all about multiple aspects of it, right? Including ERPs and MES as well. So what should we do to get to the Industry 4.0, right? So I would, my strategy has always been, crawl, walk, then run, and then, faster. Basically, you have to start small, very, very small. You have to understand a specific problem. You have to understand what that problem is being caused by, right? You have to go to the reasoning of that particular problem. You have to get the good data which has already been collected. You are not going to, even believe when if I tell you, like, how much data we have in our silos which is not being reused or even utilized or even looked at by our industry professionals, because it's just lying there and nobody really cares about creating patterns out of it. Nobody cares about thinking how I can reutilize the same data. So basically, this is all about reusing the same set of data and creating insights that actually will help you. So how you are going to reduce the maintenance costs using data, right? If we take a look at different approaches to maintenance, and yeah, you can start with basic reactive maintenance, which is actually sorting out the mess after it happens. And a lot of people, majority of people doing are preventive, either the time based or it might even be usage based, right? We will lubricate once a week, or we are going to lubricate every X hours of runtime, right? Then condition-based maintenance has been around for many years, but numerous people are still not doing condition-based maintenance, and that's using a piece of data to decide when to do your maintenance. It might be a vibration sensor or something else like that. But again, if it's pulling that data and then you get into there, you can create, a more complex, more predictive or more prescriptive maintenance as well, which we'll talk about more in a second. But all of these results you are getting more, from moving from manual to automated, to more autonomous kind of thing. And basically all of this is going to improve the business performance. So basically you are changing the approach to your processes, your norms, and you are getting more complex, and you're doing your maintenance when you need it and before a catastrophic problem occurs. So if we did a bit of more on predictive, so predictive is talking about multiple variables. You are getting different sensor data coming in. You are looking at creating models to predict what that is, and yeah, it's going on. So look for patterns, basically what you are looking at is there are different techniques for predictive maintenance. Like how, if you are going to do predictive maintenance or condition-based maintenance, then these are some of the techniques that we follow, which are thermography, ultrasound, vibration analysis, and oil analysis as well. And while you take a look at all these, basically when we talk about prescriptive, now that we have seen what predictive is like, right? Now we are talking about prescriptive maintenance. So prescriptive maintenance is more, about utilizing what, because predictive was all about finding that problem and finding a solution for that problem. Now we are moving to a more automated approach, like, you create your own neural networks, you create your GAN, and basically you throw your problems, your old data, your new incoming data, live data, you create a separation between them, and then the system will decide what we should do about that data, or when the problem, it has to predict when the problem is going to have occur, but at the same time it has to try and prevent it automatically without any human intervention. So I have a very interesting use case afterwards, which I'll tell you, where we used prescriptive maintenance as well. So whenever you are joining a new industry, you have to think about what kind of what level of maintenance is, your organization currently is using, and whatever state it may be, going to the predictive and to prescriptive will definitely help your company get better benefits and get good results out of everything. So if you think about, if you look at, take a look at this, right? This is basically a term that says early detection equal to reduced cost, right? And most of you have seen this picture, right? If you are using techniques like oil analysis, ultrasonic, it gives you that early warning, right? And if you look at the blue line, look what happens to the energy usage, right? As you get closer to the failure, and look what happens to the cost of repair, right? I came across an example a couple of years back when the company was doing vibration analysis, and they had the specialist team, very specialist team, which actually looks at the oil data and vibration sensors only. And unfortunately, even though they gave a good analysis out of it, the engineers in charge didn't take any because we went in, we acted on that data, we gave them the charts, analytics, and even some insights like when we should change, and gave them a complete schedule, but they didn't implement that, right? And something that could have been a 10,000 rupees bearing change turned into almost 3 lakh rupees worth of upgrades and major rebuild, basically. So this is what can happen if you don't look at your data, and even if you look at your data, you have to take that action, right? And when we have humans in place, humans in any of the chain, there is a chance that they will have their own philosophies, they will have their own things that they will decide to work on, rather than just going ahead with the data. So we talked about data, we have talked about data plus context equals information, right? But there's an extra step here, which means if you add maintenance to information, that will basically save you a lot of money, right? I mean, this was all about IIoT and Industry 4.0, and now I'm going to run you through some of the use cases that I have worked on, right? And the simplest one that when I was a fresher in company, I started, one of our earliest clients was Rishabh Instruments, which is the global manufacturer or white level manufacturer of electric energy meters throughout the world. They are the best in the industry, and they had one of the biggest problems that they had all of their data in silos. Okay, so what we decided when they came to us, when they thought like we should be reusing this data, how we can make use of data, how we can create analytics out of it. They came to us and we gave them an option to because they already had a data. So whenever they are testing energy meters, they just put energy meters on the each meter on a board, and then they give power to that. And based on the ratings, they will write down or just click on check boxes. That's it. And all of that data was pending in MySQL server that they had. So what we told them that we can start with very basic thing. We can daily take out a dump of that data every day and create analytics out of it. So the next day you will have everything available. And for analytics, definitely because the CIO level people wanted to have a look at the data without coming in to the factory floors. So we send that data over to the cloud, and we even built some of the Power BI applications for them, which actually gives them a better insight. You can even ask natural language questions to the Power BI platform, like what was the downtime yesterday, even as simple as that, and it will give you exact natural language answers back just based on the Excel sheets. So once that was done, they wanted to get more complex, right? And as I said, the meter testing was very basic system. They just had one person for each meter. So we created a setup for them where they can host multiple meters at once. Then we added a camera which will actually take photos of the meters when the energy was provided. And based on that, we created a local analytics. We gave them a web server which actually analyzes the images and again feeds that MySQL as well. So the work that the person was doing, which was again which had a very high error rate as well, right? In terms of QA, because they are a global manufacturer, they have to be very very careful about those kind of things. So when we gave them this setup, which actually worked on the local basically edge server, they also wanted to implement it at cloud so that they can make use of all this data at the global level and get a better view of their manufacturing facilities and get a real-time view of how many orders that they can pass through the QA every day. Second use case was about one of the pump management systems. So one of the biggest factories in Nashik, they have a lot of pumps, right? And what they used to do is at every nearby end of the month, because the mechanical companies are very manual and keeping data is very tedious task, right? So what they used to do is one person was allotted to collect the data, and they would have to calculate the compliance of the pumps basically. So by end of each month, that person would go to all the pumps, get the reading for the pumps, and then come back, right? And it was at the end of the month. So that data will be analyzed by the next month, right? By next probably first week or even the second week. And then what the insights that you would have were for the previous month, right? So then the company managers would come to you like, why this is out of compliance, and there's nothing you can do about it because it's the past data, right? So what we did was we came up with spare pump compliance system where they can actually allot multiple parameters, then give you all the details about that pump in real time because they already had sensors on them, and it was feeding us the data through Modbus. We just collected that data in real time and showed them that same data over our web application, which actually helped them analyze the compliance in real time, and again reduce the wastage as well. So based on these two, what we thought, like we should be building a product of this because these were individual solutions or basically silo solutions. So we created a complete product from ground up, which was module agnostic, which was communication protocol agnostic, which was OS agnostic, and even hardware agnostic as well. You can run it from Raspberry Pi, which comes cheap, very cheap, like a $5 thing, up to your own industrial grade gateways as well. So this is a simple web application which would allow you to collect data from your industries, from your smart farms, from smart buildings as well. And these are some of the modules, like regular modules that most of the IoT systems have, which are user management, protocol management. Then you can create rules based on that data that you have received. You can send alert notifications or take even preventive measures and actions based on that. Once we were done with this, we needed something, because again, the IoT sense can be implemented at one place and collect data from multiple devices. But what about a property manager who wants data from multiple such properties, right? So we created a gateway hub which would collect data from all of these IoT sense gateways. So it will be kind of a single interface for all of the IoT sense implementation. Once that was done, Industry 4.0 or WIP 4.0, which is the Industry 4.0 product that we created, uses the IoT sense at its core, helps you get the data from your machines, then organize it. Sorry, was there a question for me? I think we can take it after the session, if that's okay. So basically, organizing machines by type, location, so that you will have clear view of factory. You can raise alerts based on environmental factors, machine data as well. And again, you have your own dashboards for OEE parameters and all the KPIs that your C-level people have set, right? And this is the product that we created, which actually gives better view of your inventory. It gives you better view of your factory in real time, like what is happening. And once we implemented this in one of the MSME companies, basically, because they were a vendor for a bigger vehicle manufacturing company, when the bigger entity saw that this implementation is actually giving them insight on how the production is going to go for end of the day. And the thing about bigger manufacturers like Tata and Mahindra and Maruti is that they are completely reliant on the sub vendors for them, right? Even though a small company in Pune, if it cannot produce, let's say, 1,000 bolts in a day, then a complete car manufacturing will stop in the Tata plant, right? So just because of that one thing, the bigger things should not stop. So that's why even bigger companies have started adopting these things and making these kind of things mandatory for all the smaller vendors to get real-time visibility into manufacturing processes. My third use case is actually about the prescriptive maintenance. JOST is the Indian company which actually manufactures heavy vehicles that are like forklifts and the vehicles used in airports for carrying larger goods as well. So because they had completely mechanical systems, they wanted to create a cyber physical network of their existing infrastructure. So what used to happen is they have clients all across India. All of the airports are their clients basically, and whenever there was a fault with the machine, they would end up sending one of their engineers who would go there, check on the machine, get the parameters from the machine, check what are the parts that are required, place the order for the parts, and wait for the parts to arrive, and then fix that machine as well. And then basically that was a lot of wasted time and man hours as well. So we implemented IoT sense on a single PCB, custom manufactured PCB board, and even had the cloud communication capabilities through GSM, which allowed us to directly get data from vehicles, CAN bus communication, and feed that data into a local threshold-based analytics system, which would give you alerts based on oil levels, vibrations, and even how many times the brake is used, so that you can detect driving patterns as well. So once we implemented that, the downtime has been reduced by 20%, because whenever there was any alert from the system, the system could automatically place an order through its ERP for specific parts if the failure or about to be failure, because there were predetermined thresholds through a machine learning platform, a separate platform. So we were able to set that threshold, and the machine was able to place requests for the products through their ERP systems. The fourth use case that I worked on is one of the largest dairy farms that we have, and what they have is state-of-the-art facilities for all the cows and buffaloes that they have. It is basically a very good facility because it is digitally managed and already monitored. They have all the silos which are imported from Sweden. Most of the software systems are from Germany, and again, they are taken care of by very high-level professionals who are trained in those kind of things. So when we went there, we visited the plant, we visited the whole setup. It was really clean, really neat setup, and even the feed that was being fed to the cows and all the cattle was being monitored. So, but they had one problem, like they basically a cow is a production system for them, right? Basically, that produces milk for them, and whenever a cow falls sick, it takes about 4 to 5 weeks for the cow to get back into production. So they cannot use that cow for milking. And what we came up with was a customized band. So we used MI bands, earliest versions, MI band 1, which had a backend for altering its protocol of communication, and even we even mapped cows length based on like how much the cow is going to walk, basically. So footstep monitoring system, basically how much the cow has walked, was created by editing some of the firmware that the MI bands had, and we fitted each of the cows with those. And the cow, whenever the cow would come back at the end of the day, the communication bands will try to send that data to the nearest gateway that we had installed, and individually each of the cows will go through one of the doors where the gateway was installed. So we collected all the data, and based on how much the cow has walked and how much she has ate, by correlating those two parameters, we were able to predict when the cow was going to fall sick, so that they can take her out of the production early and start treating her separately. So that would reduce the downtime from 4 to 5 weeks to only 1 to 2 weeks, and she would be back to production within 1 to 2 weeks, and that is 3 weeks of saved downtime for them. Once this was done, since they have all the things automated, even their silos, milk silos are automated. So we even tapped those silos and started gathering data from individual cows who is going to start. We basically started predicting how much the cow is going to how much milk cow is going to produce. And again, these are some of the very interesting use cases that I worked with IoT Sense. Since my move to Rexnord, because Rexnord is the conglomerate, manufacturing conglomerate, basically, they have their own factories and everything. So when I started with Rexnord, the first project that I implemented was product portfolio using augmented reality, where whenever our salespeople will go out, they will just hand out a visiting card to the other people visiting stalls, and that would take client to need to have to go to a laptop or a digital system, open up our website, go through our product portfolio, and then find what they need, right? So just by scanning, what we did was just by scanning the visiting card, you will have you will be basically redirected through your phone to our complete portfolio, rather than just going to have to the trouble of going through our website. And even there were segments, that interactable segments, where you can select which product you want to look at, or which product segment you want to look at, and based on that you can drill down on the available shapes and sizes. There were configurators, and even some CPQ platform integration as well. Then we started with because we wanted our clients to go with just the portfolio experience. So we started giving them the realistic exposure of what the size will be. So because we manufacture our own gearboxes, and if the customer could actually see its dimensions in its place using augmented reality, that would actually be a better experience rather than just client measuring their own space and then thinking about, yeah, this will fit or not, right? So this gives them a very better visual experience overall, and this would increase the customer satisfaction as well. And the last was implementing the AR, because we were already collecting different parameters like vibrations and oil levels, everything to our platform. We just wanted to map those with individual machines, and using Unity platform, we have done that. So whenever you move around in our factory using your own application, with obviously with authentication and authorization, you will be able to see the live parameters as well on the machines using our own mobile app. So when I talk about so much about automation, right, you must be thinking about, yeah, this will reduce the number of jobs we have. This might even reduce, workforce. But the thing is, what we are trying to eliminate is not the human factor, but we are trying to eliminate the inefficiencies in the system, right? And machines are much better at doing redundant things. Machines are not good at thinking new things, right? So we can, basically, obviously learn new things. We can upskill and make our jobs more relevant by, having higher standards of learning, and again, having better jobs as well. Because again, we will be freed from these kind of menial jobs. So the pointers here are, you need high quality, reliable data to actually, feed to the system, which will actually eventually give you insights on that data. And your data isn't just a bunch of things that you can ignore or just look at and just have a few comments. You have to work on those. Until and unless you work on those, it's just going to be useless. So what we have been able to achieve so far using Industry 4.0 and IIoT implementation is up to 30% less in maintenance costs, and considerably reduced unplanned downtime as well, right? And to get started on the implementation, what you have to do is stop working on a problem when you face the problem, but rather start from a basic problem, start from the data that you have, and work on it, find out the reasons of the problem, collect the data, think about it, and implement the better solution that will work for your specific use case, rather than just going with a generic platform. So that's all from my side. Do we have any questions?
So participants, any questions on this slide? Just raise your hand. We'll check out.
Anything related to IoT, IIoT, even in the augmented reality?
Yes, sir. After you please ask.
Yeah.
Yes, sir. Good afternoon. Sir, my question is, so in case of industrial 4.0 scenario, why not use HTTP or SIP instead of MQTT?
Okay. So HTTP, why not use HTTP? You mean?
Yes, sir.
So basically, HTTP requests are very large in size. They have bigger overheads as well. When you look at the HTTP request format, right, there are so many factors involved, correct? But what your fridge needs to look at, right, when it's going to talk to your router, saying that, yeah, my milk is, I have very less amount of milk left, or I have only 3 eggs left in the fridge, right? If you want that kind of information, your fridge doesn't need to send all of that information, right? Like the overhead part, basically, that's what I'm talking about.
Yes,
But MQTT, what it enables your fridge to do is, yeah, just tell me the amount of eggs or number of eggs that I have left, right? You just create that particular topic, and whenever the weight of the eggs changes, then your fridge is going to send just the number of, or basically the weight of the eggs, right? And your program is going to convert that into number of eggs, and again, that only that number will be passed on, right? So this takes lesser energy, this takes less amount of data, and again, it's optimized, right? So obviously, HTTP systems are helpful when we are talking about very high security systems. We are talking about where there is a lot of data involved, like even files if we are sending, right, for your security cameras, right? Now, obviously, they are over RTSP and video transmission protocols. But if you want to get the data from DVIs or other silos or DCs, right? So in that term, even though you are receiving IoT data, it is better to send that data into HTTP, right? Where if you are sending data over to the cloud from your local gateway, then it makes sense to send your data into via HTTPS rather than just sending over to MQTT, because it's going to be a large data, like it's a collection of data, right?
yes, sir. Sir, does the inclusion of a broker in case of a MQTT system enhances the IoT capability of a better security solution?
Yes, so definitely it actually, when we are talking about client server architecture, the overhead of extra work, right, including security, including message passing mechanism, including its responsibility to make sure that the message has been received or not, everything falls onto those two entities, right? Which means you have to increase the performance. You need better hardware, you need better RAM management. Everything has to be better, right? But if we just think about MQTT, where you are just only responsible for sending the data or receiving the data, that's it, right? So all the responsibility will fall onto the central management authority, right, which is going to be your broker, and he can definitely better manage. So you are just spending all of that money into one place rather than spending it into consumer facing devices, right? So that will reduce the production cost, and again, because gateways or MQTT brokers are cheaper in terms, because you are just going to buy one, right? So for all of the smart things that your home has, so it makes more sense to put all that responsibility with the router or the central broker authority rather than just putting into regular devices.
Thank you, sir. Sir, does infrastructure as a service act as a broker as well?
Again, infrastructure as I don't think I went in too deep, because again, we were going to focus more on IIoT, but infrastructure as a service is basically where you rent PCs, okay? So
yes,
cloud is nothing but other person's PC, right? You're just not looking at it. And while you don't even have to maintain it, you still have to take care of all the things, right? So infrastructure as a service means that instead of buying the hardware, you're just renting, that's all. So everything that falls with you in your regular system, that when you buy the hardware, when you buy your own laptop, when you buy your own gateway, right? All of these things come have same kind of problems you will face with the infrastructure as a service. The only point will be where if you want to upgrade or if you want to downgrade, then you won't have to worry, because those are not your hardware, right? You're just going to let them go, that's all.
Thank you, sir. Thank you so much.
So regarding Subramaniam's question, is there any regulatory body to control these IoT or IIoT, right? So Subramaniam, there are a few forums and consortiums who are creating new standards, but since this is not a proprietary thing or even a technology, right? As I mentioned, IoT or IIoT are not technologies. These are just the umbrella terms for the things being used, because again, there could be so many technologies, previous ones like SCADA, PLCs, upcoming ones like 5G and LoRa and NB-IoT and all these, right? So this is just a term, right? Terminology basically to refer to all these technologies when we are talking about a single vision of things, right? You are just talking about getting data processing that data, analyzing it, and creating basically decision points for that with that data. Yes, I mean some of the industries have like LoRa, right? So if you want to implement a LoRa or you want to create a device which actually communicates over LoRa, you have to get certified for LoRa, right? Because that's a private entity. But when we think about Industry 4.0, Industry 4.0 will be rules or guidelines set up by government, right? So that in that case, that will be specific to that country. But when we are talking about LoRa, that is going to be reserved with the company LoRa, which is actual consortium. Those will be basically giving all the guidelines and certifications and all the membership fees and everything will be involved. Okay. Anything else? No, I guess. Thank you. So, so are there any more questions for me?
Thank you so much, sir, for this great session. I just request Madam introduce, because we are not any time to introduce because you are so energetic and you have started the great session. I'm just requesting Sushmita Madam. Ma'am, please.
Yes, madam. Thank you, madam. Very good afternoon to one and all. I am A. Sushmita, Assistant Professor, Department of EEE. So at the starting, we haven't given any welcome note for you, sir. So it gives me great pleasure to introducing the speaker, Saket Nalegaonkar from Rexnord Corporation. He is presently working as a senior application developer at Rexnord Corporation, and he handles many projects in his career, connected water management products, augmented reality for enhancement, client engagement, and blockchain-based distributed compute sharing platform. And he has more than 6+ experience, including this NOSCOM's Emerge 50 award winning product development. So thereby he interviewed by the Economic Times of blockchain expertise. And coming to his qualification, he has studied a Bachelor of Engineering in Information Technology, Dr. D.Y. Patil Institute of Engineering and Technology, University of Pune, and he postgraduated from Nalegaonkar Institute of Management, Mumbai, in Diploma in Business Management, International Business.
Thank you, Sushmita ma'am. Thanks for the introduction.
Great.
Sorry I barged in earlier. I mean, I thought I was late to join, so that's why I started directly. But thanks for all the response. Thank you everyone for listening to me.
Thank you, sir. Thank you for accepting our request for this, for requesting for one session in this ATAL FDP.
And I hope this was informative for everybody. I have a blog where I regularly post about IoT and industrial IoT innovations and new trends as well. So if anybody is interested, they can head over to Quixotech blogspot, where I usually post. And reach out to me in case anybody wants to pursue career in IoT as well. Thanks.
Yeah,
Thanks a lot.
you have discussed so many things related to the communication things, IoT, Sense, Industry 4.0 and various industrial resolutions. These were very informative, and I am sure the participants would be benefited from this talk.
Thank you.
Thank you.
Thank you, Mr. Saket, sir. From the coordinator side, it's really it was nice to connect with you. And so lecture is really an excellent lecturer about industrial IoT and Industry 4. Thank you so much, sir. I'm again just giving my vote of thanks to you, the Department of EEE at the Vidyaprashad College of Engineering. Thank you very much.
Thank you. Bye.
Bye. So dear participants, we'll meet at the 12. We'll meet at the 2:30 after the lunch break. I have already just shared the session details in your mail ID. Again, I'll share the session details in the WhatsApp group. So this is the 20 to 25 minutes arithmetic function. After that, immediately before 3, we'll go for your test. So, and the test questions also I'll just share with your mail ID. Not I'm not going to share for this chat box because some participants are giving problems in chat box, so they're difficult to access. So no problem. We are going to send the completely examination, the test link to your email ID. For a WhatsApp group, we cannot share the examination group link. So we'll share in the email ID. If anyone has any problem with the email ID, they are not getting the proper mail, you please just message us your mail ID so that we can send it. Yeah. Thank you so much. So see you. Just go for the lunch and see you after the 2:30. Thank you very much.